Welcome to the fascinating world of computer science. Whether you are a total beginner or just curious about how computers actually work, you are in the right place. Today we are going behind the screen to uncover the secret language and inner workings of machines we use every day. We'll focus on three core ideas: language, memory, and the microprocessor. But before that, welcome to my channel. I'm Pavel, I work in game development, and I'm a former graphics developer and researcher with a PhD in computer science. Computer. At first, it feels like a mysterious black box. It doesn't do much unless you know how to talk to it. Let's start simple. Pretend you are holding a number 5. Now, say you want to bump it by 1. So just add 1 and you get 6. Want to drop it down? Subtract 1. That gives you 4. These two actions, increment and decrement, are the most basic instructions you can give a computer. It's just like saying, hey, could you just tweak this number a bit? Easy. What's interesting, computers don't need you to write full words. We use abbreviations because they are more comfortable to work with. Instead of increment, we might just say INC, and for decrement, DEC. Now let's talk about memory. Think of a computer memory like a basic spreadsheet. Each cell can hold a number or piece of information. Say we have two cells, cell A and cell B. You might want the computer to remember the number 5. So you give it a command: move 5 to cell A. The keyword here is MVI, short for move immediate. Sounds technical, but all it means is place this number directly into memory. Let's do one more. Move the number 8 to cell B and boom, now you got the values stored and ready. Now for something cool, registers. These are like hidden pockets inside the computer's brain. Super fast, super efficient. So when you MVI 5 to A and then INC A, what's happening behind the scenes? The number goes into register first, think of it like an ultra-fast holding tray. Then the computer says, okay, I'll add 1. 5 becomes 6. And that change happens at lightning speed. You can even try this in a simulator. First, we move 5 into cell A. Done. Now we increment it, and there it is. We get 6. But how does computer know what to do with all these commands? Microprocessor is the answer, the brain of the computer. Inside it lives something called the Arithmetic Logic Unit, or ALU. Now, don't let the name scare you, it's just the decision maker that handles math and logic. Let me break it down. Picture two light switches, one on the left, one on the right. If both switches are off, that's 0, in binary, no electricity flows. The bulb stays off. If both are on, 1, electricity flows and the bulb lights up. If only one is on, some systems still light the bulb. These behaviors form the basic of logic gates, tiny decision-making circuits. Two of the most common types are AND and OR. Here's a quick example. AND means both inputs must be on for the result to be on. OR means either one being on will do the trick. This kind of logic is baked into every microprocessor. It's how the computer decides what happens next. Let's tie this back to incrementing. Say you start with the binary number 0010, which is 2 in regular numbers. Now, if we OR it with 0001, which is 1, you get 0011, and that's 3. Just like that, you've incremented 2 to 3. Not by additional addition, but using logic gates. And that's the brilliance of the ALU at work. Just a side note, real arithmetic operations are more complex than this, so take it as an illustration only. When it comes to logic gates, it gets better. There's a famous chip called 7400, made entirely of NAND gates. What's wild? Every logical operation and or not even complex math can be built using just NAND. It's like having a toolbox with only one tool, but somehow that one tool can build an entire house. Try this. Load up a 7400 simulator online. Flip pins 12 and 13 to on. You'll notice pin 11 goes off. That's the NAND gate doing its thing, blocking the flow unless both inputs are on. So this isn't just a theory, it's a real hardware running a real logic. Let's bring it all together. Imagine you've got a computer in front of you. First, you need a language to talk to it, a set of commands like MVI, INC, or SUB. Next, you need memory to store numbers, values, and results. And finally, you need a microprocessor to understand and carry out those commands. Inside the processor, It's all just ones and zeros, but when orchestrated together, it becomes your music player, your search engine, your video game console, everything. And this is just the beginning. There's a whole series for you in my channel where we'll dive deeper into how memory is structured and how the CPU carries out instructions step by step. Watch it now. Thanks for being here with me. If you like what you saw and want to see more in the future, hit the subscribe button. See you next time.